Unit 1, Day 9 homework review. So sorry that we don't get to meet in person today due to the smoke, but I'm going to go ahead and go over the Unit 1, Day 9 homework on piecewise defined functions. So on number 1, here we have f of x broken into 3 parts. When x equals 3, we see that 3 is obviously between 2 and 5, so we apply 3 into negative 2 times x, which is 3, plus 10, and evaluate. So f of 3 equals negative 6 plus 10, which is 4. For number 2, when x equals negative 4, x equals negative 4 goes into x less than 2. So f of negative 4 equals 4 times negative 4, or negative 16. On number 3, looking for f of 5. 5 is in the third block. So we see that x is greater than or equal to 5. Since x is equal to 5, this is the block that applies. So our value for f of 5 is 2. And f of 2 is in the middle block, where x is equal to 2. So again, f of 2 equals negative 2 times 2 plus 10. Negative 4 plus 10 is 6. f of x, number 5, equals 2/3 x plus 1. This is a linear equation with y-intercept at 1 and a slope of up 2 over 3. But f of x is not defined for x less than or equal to 3. So if we had the whole line, we would be looking across the entire domain. But because we are on a restricted domain, we start f of x greater than 3, so it's an open hole. Does not include the point where x equals 3. And then we're going up to over 3. For f of x equals negative 4x minus 5, for x less than or equal to negative 1. Again, we look for our y-intercept at negative 5. 1, 2, 3, 4, 5. And then we're going to go up. Because it's negative, that's negative 4 over 1, or 4 over negative 1. So up 4, 1, 2, 3, 4, left 1. Up 4, 1, 2, 3, 4, left 1. Up 4, however many times you'd like to do it, left 1. 1, 2, 3, 4. And then we connect our dots, starting from x at negative 1. X can be less than or equal to, so that's a solid filled-in circle. And then we have our negative slope. Negative slope means that it goes downhill from left to right, which is why I mentioned putting x on the bottom as being our negative. We still see we go up 4, positive 4, left 1. For problem number 7, f of x equals negative 1/2 x, so my slope will be either negative 1 over positive 2 or positive 1 over negative 2, whichever way you want to think about it. Here we're going from x equals negative 6, greater than or equal to negative 6, over to x equals 0. So we see that our y-intercept is 0. We can plot that point. And we can evaluate this graph at 0 and negative 6. At 0, 1/2 times negative 1/2 is 0. At negative 6, negative 6 times negative 1/2 is positive 3. We know it's linear. So this is the other way to plot our graph, is we pick the two endpoints and we plot it that way. So either you can graph kind of visually by plotting your intercept and then applying your slope and only taking the portion which the graph is defined on, that portion of its restricted domain, or you can put f of x, x, and do a t-table. Put in your boundary edge of 3, and then pick a number larger than that, 6, 9. You'll notice I went up by 3s because there is a fraction. That just makes it easier. So again, back on number 5, f of 3, 2/3 times 3 is 2, plus 1 is 3. For f of 6, 2/3 times 6 is 4, plus 1 is 5. So we could just also 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, plot this way, whichever you prefer. Or use one to get your answer and then check. So here we have an absolute value. In class we discussed that we can find the point at which the absolute value is equal to 0, and that would be when x equals 4. 4 minus 4 is 0. So that's our turn point. Then we ask ourselves, is that within the domain that's defined on this piece of the function? Yes, 4 is greater than negative 2, and it's less than or equal to 6. So, again, option t-chart. Since we don't really have a good slope to work off of, you can calculate the slope off of that, but you'd have to do it in 2 chunks, one to the left of 4 and one to the right of 4. Instead, we'll put in our edges, negative 2 and positive 6, and we'll put in our turn point, 4. So, when we put in negative 2, 2 times the absolute value of negative 2 minus 4, negative 2 minus 4 is negative 6. The absolute value of negative 6 is positive 6. So 2 times 6 is 12. Because it's strictly greater than, that's an open hole at 12. Then we'll put in 4. At 4, the absolute value of 4 minus 4 is the absolute value of 0, which is 0. 0 times 2 is still 0. And then at 6, we have 2 times the absolute value of 6 minus 4. The absolute value of 6 minus 4 is the absolute value of 2. The absolute value of 2 is 2. So the other point to plot is the point 6, 4. Here we see that x is less than or equal to 6, so it is a filled-in solid circle. So back here at x equals negative 2, 1, 2, we're going to go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12-ish. And that's the open circle. On number 9, f of x is defined as a horizontal line at y equals 2, or f of x equals 2. For all values of x such that x is strictly greater than negative 3, open circle at negative 3, oops, and less than or equal to positive 4, closed circle, filled-in circle, whichever way you like to call it, at positive 4. On number 10, again, absolute value. Here we look for when the absolute value is equal to 0, and that is when x equals 1. That is our turn point. And this is for all values of x greater than negative 4. So we need to evaluate f of x for values of x at negative 4, at positive 1, and then something to the right of positive 1. Just for simplicity, we'll say that negative 4 is 5 to the left of positive 1, and 6 is 5 to the right of positive 1. And then we can plot those 3 points. So here we have, at negative 4, we have negative absolute value, negative 4 minus 1, plus 2. Negative 4 minus 1 is negative 5. Take the absolute value of that, that's positive 5. Then we apply the negative multiplier. It's really negative 1 times that. So that becomes negative 5. And then we add 2. That becomes negative 3. When x equals 1, we put in 1 in our absolute value. 1 minus 1 is 0. Absolute value of 0 is 0. Multiplied by negative 1, still 0. We add 2. That's the point 1, 2. And at 6, we have negative absolute value, 6 minus 1, plus 2. 6 minus 1 is 5. Absolute value of 5 is 5. Multiplied by negative 1 is negative 5, plus 2 is negative 3. And here we have our symmetry. So when we go to plot it, x must be strictly greater than -4. So at the point -4, comma -3, we draw an open circle. At the point x equals 1, we have f of x equals 2. And at the point where x equals 6, 1, 2, 3, 4, 5, 6, we again should be at -3. So, pretty close. And then on the far right side of our graph, we draw an arrowhead because x can continue to be any positive value onto infinity. So our domain would actually be open parentheses -4, comma, positive infinity. Number 11, word problem. A gourmet coffee store sells the house blend of coffee beans at $9.89 per pound for quantities up to and including. So in other words, less than or equal to 5 pounds. For each additional pound after the 5 pounds. So if we were drawing this out as a function of x, you would have one portion where it would be 9.89 times x for x less than or equal to 5. For each additional pound after 5 pounds, the price is $7.98 per pound. So when x is greater than 5, we'll have 5 times 9.89. That's the first 5 pounds. Plus 7.98 times x minus 5. Think about that for a moment. We take the first 5 pounds and we charge full price. And anything above that, we have to actually subtract 5 pounds to account for the fact that we've already paid for that coffee, and then take what's left over and multiply that by 7.98. So 3 pounds of coffee, 3 times 9.89. 7 pounds of coffee, 5 times 9.89 plus 7 minus 5, or 2, times 7.98. And that's $65.41. If you want to check it with your calculator, 9.89 times 5 equals 49.45 plus parentheses 2 times 7.98, and that gives us 65.41. Determine the cost for 5.5 pounds of coffee beans. Again, we're going to have that $49.95 for the first 5 pounds plus a half a pound. 5.5 minus 5 is just 0.5 times 7.98. 0.5 times 7.98. 0.5 times 7.98 equals $3.99. We will add that to 49.45. Sorry, using my calculator simultaneously. And we get $53.44. Now, although it's the last question asked, it was the first thing I did. So here is our function written out once again. And that was the end of day 9 homework.